All right, hi boys and girls. So for today, we are going to be beginning 16-10, which is all about lines of symmetry. So when you are discussing, let me just exit out of this, when you are discussing lines of symmetry, that basically means that it is the same on one side as it is on the other. So think of a piece of paper. If you were to fold a piece of paper in half, and you were to then unfold it, one side is the same as the other because you folded it directly in half. The line of symmetry is the line that cuts the figure or the picture, and it cuts it either in half or diagonally in half in order to make it symmetrical on one side as it is on the other, or the same as one side as it is on the other. So, for example, you can also think of a butterfly. If I were to cut a butterfly directly in half, that would be a line of symmetry because the one wing is the same as the other wing. So we're going to learn a little bit about that, and we're going to learn about how it is basically a mirror reflection. Whereas, think of if you're looking in the mirror, boys and girls, and you see yourself at the same as you are standing in front of the mirror, that is an example of symmetry. It's basically a reflection of something. So we're going to look at some examples of that, and we're going to talk a little bit more about it. All right, so let's get started. Okay. So, as I said, boys and girls, a line of symmetry, this is an example of a line of symmetry because the right side is the same as the left side. So, if I were looking at this truck, this line would be a line of symmetry, and I could say that the right side is symmetrical to the left side. That is another form of the word symmetry. Now, I also want to talk about, first, we'll talk about this shape. A hexagon is a figure that has 6 sides. So we're going to use a hexagon today as an example, and we're going to find out about the hexagon's line of symmetry. And then you also have to learn the word congruent. That is a word that we are going to be talking about today. So keep that in mind, and then when we talk about it, you'll figure out exactly what it means.
What is a line of symmetry? A figure is symmetric if it can be folded on a line to form two congruent halves that fit on top of each other.
So, as I said, I want you to understand the word congruent as well as symmetric or symmetrical or symmetry. Those are all different forms of the same word. That means basically a synonym, it's a synonym for the same. So, if the right side is symmetrical to the left side, that means that they are the same. So, what they're saying is you are trying to form two congruent halves. So, congruent means basically another form of saying that this half is the same as this half. So a line of symmetry is going to form two congruent halves that can fit directly on top of each other. So if I were to fold this picture right on this line and put this side on top of this side, they would fit perfectly because the right side is symmetrical to the left side. So two congruent sides are sides that are the same.
The fold line is called a line of symmetry. This truck has one line of symmetry.
So that is another point that I want to talk about. A shape or a figure or a picture, depending on that shape, figure, picture, you can have more than one line of symmetry. Now, in this example, this truck only has one line of symmetry because if I cut this truck directly in half right here, the right side is the same as the left. But if I were to try a horizontal line, right where I'm putting my mouse going back and forth, the top would not be the same as the bottom. If I were to try a diagonal line, this part of the truck would not be the same as this part. And if I were to try the diagonal going the opposite direction, this would not be the same as the bottom part here. So this example of this truck only has one line of symmetry, but other examples could have more than one line of symmetry. So we're going to talk about some examples that have more than one, but this is an example that only has one.
Are there any other lines of symmetry for the picture of the truck?
So we just talked about that. There are no other lines of symmetry that would work.
There is no other line of symmetry because there is no other way to fold the picture so that one half fits exactly the other half.
So, whenever you're thinking of symmetry, boys and girls, think of it as folding. That's a very, very good way to think of it. Think of when you're folding a piece of paper to make a card for someone, and you're folding it exactly in half. So, when you're trying to think, is this a line of symmetry? Think, if I had this picture, figure, shape, whatever it is, printed on a piece of paper, and I were trying to fold it directly on this line, would the top half fit on the bottom half perfectly? Because if it doesn't, that means it is not a line of symmetry. It has to be the same on one half of the line as it is on the other.
A figure can have more than one line of symmetry.
So here is an example of a figure, a rectangle, that would have more than one line of symmetry. If I were to look at this as a piece of paper, which this actually looks kind of like a piece of printer paper, if I were to fold this going this way, that would be a vertical line. A vertical means up and down, horizontal means side to side. So if I were to use a vertical line and I were to fold this piece of paper, this half would sit directly on top of this half and it would be symmetrical. Now if I were to try folding it with a horizontal line, this is another line of symmetry because this top half would fit perfectly on this bottom half. So this figure has two lines of symmetry.
Is there more than one line of symmetry for this hexagon?
What do we think?
Here are 3 lines of symmetry, each of which connects 2 opposite vertices.
So boys and girls, here are 3 examples of lines of symmetry that would work in a hexagon. So as I said, it is not always up and down or side to side. It can also be a diagonal line. Now, if I were to look at this line, this diagonal line as an example, if I were to fold this half and put it on top of this half, it would be symmetrical because it would be the same on this side as it is on the other. Now, right now, as I'm making this video, I'm tilting my head a little. If you guys tilt your head a little to the side, you will see that it kind of looks like if this figure were flipped a little, that this would be the right half and this would be the left half. Now the same goes if you tilt it the opposite direction. This half and this half would fit directly on top of each other. Now if I were to fold it with a horizontal line, this top half would fit directly on top of this bottom half. So those are 3 examples of lines of symmetry that would be correct if you were to be asked to find a line of symmetry for a hexagon.
There are 3 more lines of symmetry and a total of 6 lines of symmetry. So a figure can have many lines of symmetry.
So a hexagon is an example, boys and girls, that it can be a little confusing. That's why we started with only 3 lines of symmetry and then showed you the next few lines. Now, you'll see that this line right here, we didn't see that in the first example. If I were to just cut this directly in half, yes, that is a line of symmetry as well, because the right side would fit directly on top of the left side. Now, if I were to cut this diagonal, now we saw this diagonal in the first example, but if I were to cut this diagonal as well, this would fit directly on top of this. And the same goes for the opposite side. So this looks a little bit similar, boys and girls, to yesterday's math work where we were cutting a circle into pieces. Those are all lines of symmetry because if you were to fold this piece right on top of this piece, if this were on a piece of paper, one half would fit directly on top of the other half. If it does not, if one side is not the exact same as the other side, it is not symmetrical. It is not a line of symmetry. Okay?
Is there a line of symmetry for this figure?
So this is a very important example. Let's think about this. Okay, so lines that I know off the top of my head, automatically I think of, okay, cutting directly in half. If I cut this in half, is this side the same as this side? No, right? Because I have a little dip in. It's almost like a little cutout. But on this side, I have almost like a little bit of a bulge out of the figure. So it's not the same on the right side as it is on the left side. Now, what if I were to cut it directly in half going horizontally? Is the top the same as the bottom? No, right? If I were to fold this directly on top of the bottom, it would not be the same. Now, what if I tried diagonally? No. What about the other way? No. So let's see.
There are no lines that divide the figure into 2 congruent halves, so some figures can have no lines of symmetry.
So that's important that we recognize that, boys and girls. Some figures you'll have one line of symmetry. Some figures you could have 6 lines, like the hexagon. Some figures you could have no lines of symmetry. Because this is a very unique figure, usually when you have unique figures like this, it's a little bit more challenging to find a line of symmetry because all of the different spots are so different in this figure. Okay, so now what I want to do, boys and girls, is I want to look at 1610, our reteaching page, and I want to talk a little bit about different lines of symmetry on here. Now, a reminder, I want to read the top to us just to remind us and reinforce what we learned in today's lesson. Symmetric, I have trouble pronouncing that, symmetric figures are figures that can be folded to make two halves that match each other. The lines that divide a symmetric figure into matching parts are called lines of symmetry. This square has 4 lines of symmetry. If you fold the square along any of the 4 dashed lines, the two halves will lie on top of each other. So again, a figure can have more than one line of symmetry. It's your job to try to test out as many lines of symmetry as you can and really think to yourself, is this side exactly the same as the other side? Are these two halves congruent to each other or the same as each other? So, tell if each line is a line of symmetry. So, number 1 through 4, we have to look at the lines, the dashed lines, and decide, is this a symmetric, a line of symmetry, or does this create two symmetric pieces or halves? So number 1, I think we should easily be able to look at this and say no, because if I fold, this right side is a lot bigger than this left side. So the answer to this is no, this is not a line of symmetry. A line of symmetry would be here or possibly going horizontally cut in the middle. Now number 2, I would say yes, because if I were to fold this top half on top of this bottom half, if this were a piece of paper, the top would be symmetric to the bottom. It would be exactly the same. They would fit right on top of each other. Now, number 3. Number 3 is the letter H, an uppercase H. Is this a line of symmetry? Would this right side fit directly on top of this left side? The answer is yes, this is a line of symmetry. Now, number 4. Again, remember I said, boys and girls, when you find yourself looking at very unique figures, not something like a square that you see often, a unique figure that you don't see often, it is harder or more challenging to find a line of symmetry. Now in this example, no, this is not a line of symmetry because the top is not going to be the same as the bottom. Now let's look at number 5 through 8. Number 5 says, tell how many lines of symmetry each figure has. So if I were to test this out, going up and down, I would say that yes, I could say that that's one line of symmetry because if the right side folded on top of the left side, that would be symmetrical. Now, if I were to try a diagonal line, I don't think that that would be symmetrical. That would not be the right side would not be the same as the left side, nor would the other diagonal line that I could form. Now, what about if I cut this top square right off of the bottom square? Would that be symmetrical? No, because the top would not be the same as the bottom. So it looks to me like this would only have one line of symmetry. Now, number 6. Are there any lines of symmetry? Could I go diagonally? Could I go up and down, side to side? No, I don't see anything that could make this symmetrical. So I would say 0 lines of symmetry. Now, what about number 7? I can't go diagonally because this would not be the same as this if I folded them over. But I can go up and down, and I can make my vertical line, and that would make the right side the same as the left side. So I definitely have one line of symmetry at least. Now, what about if I cut this directly in the center? Now, this is like an H on its side or an uppercase I. What if I cut it directly in the center? Would the top fold directly onto the bottom? It would be at the same figure on the top as it is on the bottom. Yes, it would be. So the correct answer for this is I would say that there are 2 lines of symmetry. Now, what about Number 8, if I cut this directly in half, that's a line of symmetry, definitely. What if I tried to cut this side to side? If I were to try to use a line of symmetry side to side, a horizontal line. No, because the top would not be the same as the bottom. What if I tried a vertical line? No, those aren't working. So this would have one line of symmetry if I cut directly in half. Number 9 says, how many lines of symmetry does the letter R have? If I were to cut R directly in half, that would not be symmetrical. What about if I were to cut it horizontally, side to side line? No, the top would not be the same as the bottom. What if I tried a diagonal line? Nope, that doesn't work either. So how many lines of symmetry does the letter R have? 0, right? I don't see any possible way for me to make that a symmetrical figure, to use a line of symmetry to make any halves congruent to each other. Now, number 10 says complete the drawing so that the figure is symmetric. So your job, boys and girls, is to make a side on this right side that is exactly the same as the left side. How you would do that is you would draw exactly the same as it is on the left side. Now, the reason they put this on graph paper is to make it easier for you. So you'll notice this top, it only has half of a square. So what you would do on the right side is draw and fill in half of a square. Then the second line has a whole square filled in with half of a square. So I would fill in a whole square with half of a square and continue. This has 2 squares filled in, so right next to it I would put 2 squares filled in. This is why they use graph paper to draw lines of symmetry and to try to make a figure that is symmetrical on the right side and the left side, because it's easier when you have these squares in the graph paper to count to make sure that your figure is exactly symmetrical on one side as it is on the other. Okay, I hope that this helped you guys, and I want you to try the practice page and use that to help practice your ability to draw lines of symmetry and to make symmetrical figures. All right, good luck, guys.